right now, developers and engineering teams are paying Anthropic upwards of, hundreds or even thousands of dollars a month
Yeah.
to use their premium autonomous coding agent.
Yeah, it's not cheap.
No, not at all. And it's an incredibly powerful tool, right? Like it can read your entire code base, hunt down bugs, rewrite architecture on the fly.
Absolutely. It's an enterprise-grade brain,
Exactly. But as of a few weeks ago, like early 2026, this massive back door was essentially just kicked wide open.
which is wild to watch happen in real time.
It really is. So today we're looking at how developers are hijacking Anthropic's official command line tool, severing its connection to Anthropic's billing servers, and hotwiring it to run entirely for free on their own machines.
Right, which fundamentally rewrites the economics of using AI for software development.
Totally.
Because, I mean, if you're listening to this and you've been feeling that subscription fatigue,
But fatigue is real.
right, or, if you've been hesitant to just hand over your proprietary code to a cloud server, this workaround is shifting the ground under the entire industry.
Well, welcome to the deep dive. Our source material today is this really fascinating breakdown from the OscarAI community, specifically from an author broadcasting out of Pasto, detailing exactly how this is being done using Ollama on Ubuntu.
Yeah, it's a great piece of documentation.
It is. And the mission for us today, for you listening, is to basically strip this down to the studs. We need to figure out the mechanics of this setup, what kind of hardware it actually takes to run it, and, well, what the hidden costs are.
Because there's always a catch.
Always. Okay, let's unpack this with a bit of an analogy. Imagine you have the dashboard and the controls of $1 million spaceship, but instead of paying for their insanely expensive rocket fuel, you've somehow figured out how to plug in your own solar panels.
That is exactly what this is. And what's crucial here is why this matters for you, the listener. It's not just about saving money. I mean, avoiding a $20 to $200 a month subscription is great, sure.
Yeah, nobody likes paying that.
Exactly. But it's really about achieving 100% privacy. It's about maintaining this ultra-productive agentic workflow where the AI reads your repositories, edits files, reasons step by step, but doing it entirely on your terms.
So this sounds like an absolute hacker's pipe dream, but it's real right now. How exactly did the tech world unlock this in early 2026?
Well, before we get to the catch, we have to look at the catalyst. The entire reason this hijacking is even possible traces back to a very specific update pushed by Ollama in January 2026.
Right, the 0.14 more Zorro update.
Exactly. They released version 0.14.0, and buried in the changelog was this seemingly minor detail: complete compatibility with the Anthropic Messages API.
Okay, let's look at the actual mechanics here because, API compatibility can mean a lot of things.
Oh, for sure.
Anthropic built the Claude Code CLI, their command line interface, to be like a loyal soldier, right?
That's a good way to put it.
It's programmed with one strict directive: package up the user's prompt, send it over the internet to Anthropic's proprietary servers, wait for their massive neural network to process it, and bring the answer back.
Right, and under normal circumstances, that communication requires a very specific language.
Like a secret handshake.
Sort of, yeah.
Yeah.
The Claude CLI expects to send and receive data in a highly structured JSON format that Anthropic custom designed. It expects certain headers, specific error codes, a very defined sequence of metadata.
Okay.
Historically, if you try to point that CLI at a different AI model, say some open source model running on your laptop, it would just immediately crash.
Because it wouldn't understand the format.
Exactly.
Yeah.
The local model wouldn't know how to parse Anthropic's proprietary data structure. What's fascinating here is that Ollama basically built a universal adapter.
Wait, hold on. So Anthropic built this incredible tool, and Ollama basically built a universal adapter that lets us route that tool's requests to any open source model. But doesn't Anthropic notice the API key is missing? I mean, the CLI literally demands an Anthropic API token to prove that you have a paying account.
Oh, it absolutely does.
So how does Ollama bypass that security check without the software throwing a massive validation error?
That is where the architecture of local environments gets really interesting. You have to separate what the client software, the Claude CLI, is doing from what the server is doing.
Oh, track with me here.
The Claude CLI definitely checks for an API key before it sends the request. So to get the CLI to fire, you just feed it a dummy token, like literally a string of gibberish.
Seriously, just fake numbers.
Just fake numbers. As far as the CLI is concerned, it has a key, so it packages the request and fires it off.
And normally, Anthropic server would receive that gibberish key, check it against their billing database, realize it's completely fake, and return a 401 unauthorized error.
Exactly the mechanism.
Right.
But you aren't sending this to Anthropic server.
Right.
You're intercepting that outbound request at the network level and routing it to your local Ollama server running on port 11424.
Oh, wow.
An Ollama server is designed to be completely agnostic to authentication. It receives the structured request, ignores the gibberish API key entirely because, well, it has no billing database to check, and processes the prompt through your local model.
So it just skips the bouncer entirely.
Basically. And then it sends back the exact JSON response the Claude CLI is expecting. The CLI receives a perfectly formatted answer and just assumes the key was valid. It's a flawless, localized interception.
That is incredibly clever. You are essentially creating a walled garden on your own machine where the software thinks it's talking to the mothership, but it's really just talking to the basement.
Yeah, exactly.
So since we have the conceptual bridge mapped out, let's talk about the actual construction.
Right.
How do you deploy this on an Ubuntu machine?
It's surprisingly easy, honestly.
Yeah, the OscarAI notes lay out a process that seems almost suspiciously frictionless for something this disruptive.
It really speaks to how mature the open source tooling has become. I mean, a couple of years ago, mocking an enterprise API endpoint locally would require writing custom Python middleware.
Oh yeah, setting up Flask servers, manually mapping network ports. A nightmare.
Right. Now the heavy lifting is completely abstracted away.
So the first step is just getting the local infrastructure running. You just run the standard Ollama installation via a simple curl script in the terminal.
Yep, very standard.
But the critical detail, and I want to highlight this for anyone listening because it's the single point of failure for a lot of people trying this, is verifying the version.
Oh, absolutely crucial.
If your system defaults to pulling an older stable release of Ollama instead of 0.14, 0.0 or higher, that Anthropic translation layer simply doesn't exist. The CLI will crash the moment it tries to connect.
And once that local infrastructure is running, getting the official Claude agent is remarkably straightforward. Anthropic themselves actually maintain Claude code as an official pip package.
Which is wild to think about.
It is. You literally just run pip install Claude code in your terminal. You are pulling the official, unmodified software directly from the source.
And this brings us to step 3. Here's where it gets really interesting. Normally, to execute that network interception we just talked about, you would have to manually configure your operating system's environment variables.
Right, you'd be writing export commands left and right.
Exactly. You'd have to force the Anthropic base URL to redirect to localhost, manually export the dummy token into your system path. It's a hassle.
It used to be a huge barrier to entry.
But as of early 2026, Ollama automated the whole thing with a single command. You just type Ollama launch Claude.
And when you type that into the terminal, Ollama essentially acts as a temporary air traffic controller for your operating system.
How so?
It dynamically injects those environment variables into that specific terminal session. It sets the dummy token, it reroutes the API endpoints to its own internal server, and then it boots up the Claude CLI.
So you never have to actually touch a configuration file yourself.
Never. And when you close the terminal, those temporary rules just vanish, so your system's global network settings aren't permanently messed up.
It is brilliant in its simplicity. It democratizes the whole process.
It really does. What used to take hours of back-end wrangling takes 2 seconds.
But having the CLI installed and the network rerouted is essentially just putting the dashboard and the steering wheel into a chassis. It doesn't do anything without an engine.
Right, the CLI is just the interface.
Exactly. It needs an underlying large language model to actually provide the logic, read the code, and make decisions. And according to the source notes, choosing that intelligence engine is where the real complexity of this setup begins.
Yeah, because you've cut ties with Anthropic servers, you no longer have access to their proprietary Sonnet or Opus models. You had to bring your own brain to the operation.
So what are our options here?
The OscarAI breakdown categorizes the available models into 2 distinct camps based on where the computation actually happens. You have local models running entirely on your own silicon and cloud alternatives provided by Ollama.
Let's start with the local heavyweight division, because this is where the hardware realities hit hard.
They hit very hard.
If you want maximum privacy, meaning your codebase never leaves your physical machine, you need to run an open-weight model locally. The notes highlight Qwen3 Coder as a massive workhorse here.
Oh, Qwen3 is fantastic.
It really is. It offers this really aggressive balance between how fast it generates tokens and the actual quality of the Python or React code it spits out.
Qwen3 has been fascinating to watch because Its architecture is heavily optimized for syntactical understanding, but the real standout in the local category is the DeepSeek V3.2 family.
Right.
The source notes it is hitting scores between 86 and 90% on the live code bench evaluations.
Which is a metric we should definitely unpack for a
Well,
second for the listener, because for a long time, AI benchmark scores were borderline useless.
yeah, they were terrible.
Like a model would score 95% on a coding test simply because the answers to that specific test were accidentally included in its massive internet training data. It was just memorizing the answer key.
Yeah, the contamination problem is a huge issue.
But Live Code Bench solves that, doesn't it?
It does. It exclusively tests models on leak code problems and programming competitions that were published after the model finished training.
Right. So an 86 to 90% on Live Code Bench means the model isn't just regurgitating code it has seen before.
Exactly.
It is actually demonstrating novel reasoning. It is reading a problem that didn't exist when it was created and writing functional code to solve it.
Which is huge.
For an open-weight model to hit those numbers running locally in 2026 is a massive milestone. Add in the surprising release of GPDOS 20 by, an open-weight model from OpenAI, and the local options are incredibly deep.
They are deep, but they demand a massive physical toll.
Yeah, let's talk about the hardware.
You can't run a reasoning engine capable of replacing Anthropic's Sonnet on a 5-year-old ultra-thin laptop. You are loading billions of parameters into active memory.
The notes are very explicit about this. To run these local heavyweights effectively without your system grinding to an absolute halt, you need serious graphical processing power.
Serious power.
We are talking about a dedicated NVIDIA RTX 4070 or higher, or an Apple Mac M2 or M3 running at least 32 gigabytes of unified memory.
Yeah, the VRAM requirements are no joke.
To put it in perspective, running a model like DeepSeek V3.2 locally is like keeping a brilliant, world-class, specialized engineering contractor locked in your basement.
That's a great way to think about it.
Right. Yes, their labor is technically free, but the physical upkeep is enormous. You have to provide the 24 gigabytes of VRAM just to give them enough working memory to function, and you're paying for the electricity to cool the room while they work.
Exactly. The infrastructure cost shifts entirely onto your shoulders.
Yeah.
Which is why the second category of models, the Ollama cloud alternatives, is where the vast majority of developers are actually going to gravitate.
Now, this is where I have some serious questions about the economics of what Ollama is doing.
Fair enough.
The notes specifically recommend GLM 4.7 Cloud as the ideal everyday driver. It requires zero local compute power because the processing happens on Ollama servers, yet it allegedly rivals Anthropic's own Sonnet 4.5 or 5 in complex reasoning.
That's what the benchmarks are showing, yeah.
So if I'm the listener trying to choose, it sounds like GLM 4.7 Cloud is the safe everyday sedan, while Quen 3 Coder is the sports car you only take out if you have a massive garage. In this case, 24 gigs of VRAM. Is that an accurate read?
That is a highly accurate read. It's the sweet spot for most users.
But how is Ollama possibly funding enterprise-grade compute for free? There has to be a catch there.
There is absolutely a catch, and it comes down to rate limits and ecosystem lock-in.
Okay.
Companies offering these high-tier cloud models for free are generally doing it as a loss leader. They cap your daily requests strictly. You might get, say, 50 high-quality agentic loops a day before the server throttles you or kicks you down to a much smaller, less capable model.
So it's more like calling in a high-end consulting firm. They are brilliant, and the first few hours are pro bono, but you have to watch the clock constantly.
Precisely. They are subsidizing the compute cost to build market share and train their routing algorithms, but it is not an unlimited tap.
Makes sense.
But even with the limits, the capabilities are staggering. The notes also mention Kimi K 2.5 Cloud, which is highly optimized for long-term planning.
Oh, nice.
And then there is Minimax M 2.5 Cloud. This one is particularly vital because it introduces a concept that completely changes how developers interact with their machines. Subagents.
Okay, let's dive deep into this because subagents feel like the moment AI moves from being a fast typewriter to an actual development team.
It really is a paradigm shift.
Before this, if you used an AI coding assistant, it was a linear process. You ask it to write a function, it writes the function. But a subagent architecture is fundamentally different.
But changes the workflow from prompting to delegating. Well, imagine you ask the main Claude agent to build a new authentication module for your app. The main agent looks at the request and realizes it doesn't know the exact syntax for the latest version of the authentication library you're using.
Because its training data cutoff was months ago?
Exactly.
Yeah.
In a traditional setup, the agent would either hallucinate a wrong answer based on old data or just stop and ask you to go read the documentation.
Which defeats the purpose of an autonomous agent.
Right. But with Minimax M2.5 utilizing subagents, the main AI basically acts as a senior engineer. It temporarily pauses its own task, spawns a junior subagent, and gives it a specific mission.
Oh, wow.
It says, go search the web, read the documentation for the specific auth library, summarize the breaking changes, and report back.
That's incredible.
The subagent goes out, executes the web search, compiles the data, and hands it back to the senior agent, which then uses that fresh data to write your code perfectly.
And this all happens autonomously in the background within seconds.
Yep. You are managing a microscopic development firm inside your terminal.
That is genuinely mind-bending. And the fact that the integration of web search and subagents spawning into this free Ollama bridge was just added in February 2026, it really bridges one of the biggest gaps between open source tools and enterprise tools.
It does. It's a huge leap forward.
But as we get into the reality check phase of this deep dive, we need to sober up a bit.
Yeah, we can't ignore the downsides.
Right, because the OscarAI notes are transparent that this setup is not flawless magic. So what does this all mean? The hard benchmark data shows that a finely tuned local setup gives you about 80 to 92% of the capability of a real paid Claude Sonnet or Opus model.
Which, to be fair, is a phenomenal return on investment for $0.
True. But missing that top 8 to 20% of capability has highly tangible consequences when you are relying on an agent to manipulate your production code base.
Absolutely. If we connect this to the bigger picture, you start to see the friction points.
Let's talk about the latency first. If you are running the local models, the speed at which the model generates tokens can be significantly slower.
Oh yeah, you're going to feel the delay.
Depending on your VRAM and memory bandwidth, you might be waiting 2 to 8 times longer for a response compared to the near instantaneous output from Anthropic's enterprise server racks.
Latency is an annoyance for sure, but the much more critical trade-off is what the engineering community calls error accumulation in autonomous loops.
Explain the mechanics of that. Why does an open source model that scores a 90% on live code bench suddenly fail when you put it in an agentic workflow?
Because an agentic workflow isn't just a single prompt and a single answer. It is a continuous loop of reasoning.
Okay.
Think about it. The agent has to read a file, decide what to change, write the script, run a test, read the error log from the test, realize it made a mistake, and write a fix. That might be a 20-step process.
Right, it's iterative.
If a model has a 99% accuracy rate on a single prompt, that sounds great.
Yeah, 99% is basically perfect.
But if you force it to make 20 sequential decisions autonomously, that tiny 1% chance of error compounds at every single step.
I see.
By step 15, the context window, the model's short-term memory of what it was originally trying to do, starts to degrade. Its attention mechanism decays. Suddenly, it loses the plot entirely.
Oh, man.
It starts trying to fix bugs that don't exist or deleting code that is working perfectly.
Yeah.
It basically starts chasing ghosts.
So the open source models drift off mission much faster than Anthropic's proprietary models.
Exactly.
I can't just tell it to, refactor the entire backend and go get a coffee. You have to supervise the logic chain and course correct it when it starts hallucinating.
Right. You are trading financial costs for cognitive overhead.
Yeah.
You have to babysit the local agent far more closely.
That makes a lot of sense.
Furthermore, there is the overarching fragility of the entire workaround. I mean, we are talking about hijacking a proprietary tool. Anthropic definitely knows this is happening.
That's the sword hanging over this whole operation, isn't it?
It really is.
Because if the Claude CLI is just an official pip package maintained by Anthropic, they could push an update tomorrow morning. They could silently alter the expected JSON structure of the API or institute a secondary server-side handshake that Ollama simply can't mock.
And the moment they do that, this entire setup shatters. Anyone relying on this bridge has to be hyper-vigilant about version control.
So you can't just blindly update your system packages.
Never. You have to lock your versions of both Ollama and the Claude CLI and constantly monitor the community forums to see if a new update breaks the translation layer. It is a constant cat and mouse game.
So let's bring all of this together. We've looked at the backdoor API bridge, the heavy hardware tax of local intelligence, the daily limits of cloud intelligence, and the very real threat of error accumulation and patched workarounds.
It's a lot to weigh.
It is. What is the final verdict here? Who is this specific setup actually built for?
Well, it is purpose-built for the developer or engineering team that considers code-based privacy to be a non-negotiable hardline.
Right.
If you are working in defense tech, healthcare, or proprietary finance, sending your raw code base out to a cloud API is often a massive compliance violation.
You'd be fired instantly.
Exactly. This setup gives you those advanced agentic capabilities while ensuring not a single byte of your code ever leaves your physical SSD.
And it is also the ultimate playground for the tech enthusiast who simply refuses to pay the enterprise toll.
Oh, absolutely.
If you already sank $2,000 into a high-end Mac or a dedicated Linux rig with an RTX 4070, this is how you extract the maximum possible value from that silicon.
You're putting that hardware to work.
You really are. You get to experiment with cutting-edge architectures like sub-agents and web-augmented generation without watching a meter tick up every time you press enter.
Which is incredibly freeing.
It is. Again, a massive nod to the OscarAI author and Pasto for documenting this architecture so thoroughly. It proves that the open source community is moving just as fast, if not faster, than the corporate giants.
The broader takeaway for you, the listener, is the sheer velocity of democratization we are witnessing right now.
It's unprecedented.
The capabilities that required a multi-million-dollar server rack and a team of researchers just, 24 months ago?
Yeah, barely 2 years.
They're now being compressed, optimized, and handed out for free to anyone willing to type a few commands into an Ubuntu terminal. The barriers to entry for advanced software creation are just dissolving.
Which leaves us with a fascinating and honestly slightly unsettling final thought. We just spent this entire deep dive unpacking how easily the tech community decoupled Anthropic's beautiful premium interface from Anthropic's proprietary brain.
Right. They kept the dashboard but swapped out the engine.
And that raises the ultimate question about the future economics of AI. If the intelligence engine itself, the massive language model, is becoming entirely interchangeable. If a developer can swap out an Anthropic brain for a DeepSeek brain or a Qwen brain with a single terminal command based on whatever is cheapest or fastest that day, where does the real competitive moat lie for these giant AI companies?
That is the million-dollar question.
If the rocket fuel becomes a cheap commodity that anyone can synthesize in their basement, who actually controls the space race? Is the real value in tomorrow's tech landscape going to be the raw intelligence of the model, or just the sleekness of the interface that we use to command it?
It really makes you rethink who's going to win this market in the long run.
It absolutely does. That is something to keep in the back of your mind as you watch these open source updates roll out. Thank you so much for joining us on this deep dive. Go fire up your terminal, pull down the latest Ollama update, and see how well that hijacked spaceship flies for you. Keep exploring, and we'll catch you next time.